Welcome back to the channel, guys. This is Joseph from Moralis, and in this video, we'll be learning how to do a transaction on Avalanche without paying any gas fees. And this simple dApp right here will be the final product of this tutorial, where here, as you can see, there's a string that is stored on the smart contract, and I'll be able to change the state value just by a simple MetaMask signing and no gas fees at all. And to really demonstrate that you don't need any gas fees to do this, I have prepared a MetaMask account that have 0 AVAX. So to do that, just really quick, edit storage. And I'm going to change the storage, the string name into Hello Moralis. And then for the signature type, I'm going to choose EIP712. There's also personal type, and I'm going to explain further later what is the difference between both of them. And then to execute the change, just set storage and a MetaMask prompt should appear soon. And as you can see, I just need to sign. No gas fees need to be spent. So just really quickly, just click sign right here. And in a few moments, the string should be updated and the changes will be reflected automatically. And boom, there you go. Of course, since this works on Avalanche, you'll be able to apply all this to other EVM change, as you can see here, such as the Ethereum, BSC, and Polygon. These are testnet, but of course they apply to mainnet as well. And we'll be learning how to do all this by using both Moralis and Biconomy. For those who are new to the channel, Moralis is a Web3 development platform that offers you a unified cross-chain SDK and also a backend infrastructure that can help you and your team integrate your smart contract in multiple blockchain and scale up your dApp easily. If a new chain becomes popular, your dApp can quickly integrate it easily with Moralis. This will for sure save you a bunch of money and time for development, bringing your dApps to the market faster. And in this tutorial, we'll be using Biconomy as an infrastructure that will help us do gasless transaction. They have various products under their product menu right here, but the one that we're interested in is the gasless feature right here that we will integrate within the tutorial with the Moralis SDK to do gasless transaction. Plus, we'll be using the Ethereum Boilerplate right here to build our dApp because it is the best Web3 boilerplate out there to build our dApps quickly and easily. Also, it integrates well with the Moralis SDK. So if we scroll down right here really quickly, as you can see, there are a bunch of components and hooks that is provided by the Moralis team out of the box, and we can use this to for sure shorten our development time even further. If you found any trouble on the tutorial, just go to the Moralis forum here. I'll put the forum link down in the description and we'll help you as soon as possible with your problem. Also, don't forget to like our videos and subscribe for more Web3 tutorials just like this. Now, before we start developing our dApp, let's first understand on high level how gasless transaction works. In normal Ethereum transaction, basically the user will use their wallet to execute transaction and the user will be the one that pay the gas fees. On the other hand, in gasless transaction or meta transaction in formal terms, the user will instead sign the wallet as I demoed earlier, and this will in turn tell the Biconomy relayer that we are the one that want to make the transaction, and the Biconomy relayer will then make the transaction on our behalf. Keep in mind that gasless doesn't mean free, it just means instead of having the user pay for the gas fees, we, the developer, will do that instead. So when doing this, make sure that there are enough AVAX on the Biconomy relayer. Then the transaction will be executed through this trusted forwarder, which will do all this stuff and then forward the transaction to our smart contract, which must be EIP 2771 compliant. In short, EIP 2771 is a secure Ethereum standard to do native meta transaction. Smart contract that inherits this basically will be able to receive meta transaction from a trusted forwarder that I showed before. And the contract, we don't need to deploy it anymore because it will be provided directly by Biconomy. So without further ado, let's start developing our dApp. So to start our development process, the first thing that we need is to have a free Moralis account, which you can get just by clicking the sign up for free button, and it will be redirected to this Moralis dashboard. But if you haven't have one yet, it's gonna take a few minutes and you just need to follow the process. But you have one, you'll be redirected to this dashboard, and once that's done, you just need to create a new server, and we're going to use a testnet server. And here we can choose the name as meta transaction server, and then just choose any region that you want, preferably the nearest to your location. And then you can choose any chains that you want. In this case, I'm going to choose Coven, Polygon Mumbai, BSC Testnet, and Avalanche Testnet. And by the way, this for this tutorial, we're just going to focus on the Avalanche Testnet, so make sure you have this one. And once that's done, just add the instance, and your server will be created in just a few minutes. Once your server is created right here, the next thing that we need is a Biconomy account. So here, just go to the Biconomy website and go to the dashboard. And here, basically, you need to sign up for a new account, and it's going to be free as well. And it's going to take a few minutes for you, but if not, then just log in and you'll be redirected to a dashboard page like this one. And we'll come back later when we're setting up the Biconomy in our dapp. Once all that's done, then we can just go to the GitHub repository that where I'll put the link down in the description, so make sure to check it out. And we just basically need to clone the repo to our local machine. So go here and then just copy the link and then open your terminal and then go to any designated directory that you want and git clone it and paste. And then just enter, and in a few moments, this repository for the dapp will be copied locally on your local computer. But I don't need to do that, so the next step will be just to open your favorite editor. And in this case, I'm going to use VS Code. And basically, this is what the directory structure for the dapp will be. And as you can see, it's basically a React project with a travel project inside of it. And the only two files that two folders that we really need to focus on is the src right here, which gonna contain all the React UI and logics, basically everything front end related, and also the truffle project right here, which gonna contain all the smart contracts logic and deployment and etc. inside of there. And to set it up before we start working on it, basically we need to first yarn install. So basically install the dependency. You can use yarn, or if you want, you can use npm install, whatever you choose. So I'm gonna do yarn, but because I already did it, as you can see, there's yarn log, so it doesn't take too long. Also, we have a travel project right here, and we need to install the dependency as well for this one. As you can see, there's a package.json inside here. So go to the truffle directory, and then once you're there, also yarn install or npm install, so that you can generate log files such as yarn.log right here. And the other thing that we need is the environment variable. And basically here, as you can see, I already have .env.example, which you can basically just copy, and you just need to fill in all the informations right here. And there's the Moralis application ID, server URL, speedy nodes, and Biconomy related API keys. We're gonna skip the Biconomy API key later until we deploy the smart contract, but basically we're gonna fill in all this. And for the application ID, server URL, and speed node, it's gonna be right here. Basically, go back to your Moralis admin dashboard and then go to your server and click view details, and then go to it's gonna be right here basically. So the application ID is gonna be this one, and the server URL is gonna be this, and basically you just need to copy both of this information and put it into the .env file. I'm not gonna show this because there are some sensitive informations, but basically this is where the application ID will goes, and this is where the server URL will goes to. And for the speedy nodes key, it's gonna be very simple as well. Just go to the speedy nodes section right here, and suppose we want the Avalanche testnet, and basically you just need to focus on this one, the Avalanche testnet Fuji, and then these are the random numbers between these links. As you can see, they're all gonna be the same. Basically, just copy them, and this is sort of gonna be what is the API key for the SPI node, so that you can deploy your smart contract through the nodes and etc. And so once that's done, that is gonna be basically the .env file for the React project. As you can see, it's on the root folder, but there's also a .env file on the truffle project, as you can see. And there are a bunch of things, as you can see here. This ether scan, polygon scan, and etc. until snow trace are quite optional. Basically, this is gonna be used mostly for verifying our smart contracts from the CLI, as you can see. But if you don't want to, of course, you can just comment this out, and don't need to fill in this part. But the most important thing is gonna be this one, which is the Moralis PD nodes key, which is gonna be the same as what we used before. And also the archive is gonna be either true or false, and it indicates whether we want to use an archive node or a non-archive node right here, and it's optional. So it's all up to you guys. So once that's done, yeah, just basically the same. And the next thing is gonna be making a .secret file. And this .secret file, basically, if we see here in the truffle config.js, it's gonna be where you see, like, it's gonna read the file .secret, and it's gonna contain the mnemonic. So basically, you just need because we will interact your uh, with your wallet when deploying the smart contract. Basically, you need to put your mnemonic, or it could be also the private key, but in this case, I'm gonna use the mnemonic. And yeah, so just make a .secret file right there on the truffle project, and input your 12-word or 24-word mnemonics right there. And once that's done, basically, we're good to go. So let's first start with developing our smart contracts first. And to do that, basically, I'm here on the Truffle project, and I make it the root folder right here for convenience, so we can just focus first on the Truffle project. But you don't really need to make it your own root folder. But basically here, there's 3 folders that we're gonna focus on, which is the contracts folder, list folder, and the migrations folder. For the contracts folder, there's going to be 2 files. The first one is going to be the migrations.sol. This comes out of the box from the Truffle project when we initialize it, and we don't necessarily need to change anything for this project, so we're just going to leave it be. And the second one is going to be the simple storage.sol smart contract, which is going to be contain the implementation of the smart contract that I demoed before earlier, where basically the requirement is that using the smart contract, we'll be able to store data inside a variable, and also set the variable to anything, any string that we want. And as you can see here, it's a simple storage, and the data is going to be stored in this data string storage variable right here. And the getter and the setter function is going to be defined right here below. You see, as here get storage, and we're just going to return the data variable. And if we want to set the storage to a new value, we're just going to pass in the new data variable, and then set the data into the new data variable right here. But of course, if we just have those, it's just going to be a really bare bone smart contract, but no native meta transaction will be enabled. And as remember, to enable native meta transaction, basically we need to make this contract to be EIP 2771 compliant. And to do that, basically the contract first needs to inherit this base relay recipient smart contract, which we will import from at OpenGSN library right here. If you install the dependency, you don't need to do that anymore because I already included in the package.json. So yeah, just import it, and then make your simple storage smart contract, or any smart contract you want to develop in the future, to inherit this base relay recipient. And once that's done, the 2 functions that we need to add is gonna be this set trusted forwarder, and the version recipient. So basically, this version recipient is gonna be any version that we want. In this case, since this is the first version, we're just gonna return it as 1. The second one is gonna be the set trusted forwarder, which basically in the beginning, if you see here in the constructor, we initialize it using the parameter from the constructor at first, but in some case, Biconomy probably will want to upgrade their smart contracts and probably deploy a new trusted forwarder for security reason, or upgrade it for an upgraded version, and we might be wanting to use that upgrade version instead of the old one. So in here we we define a set trust forwarder function to set a new trusted forwarder address in the smart contract right here, the set trusted forwarder. This is basically the underscore one is gonna be an internal function that we inherit from the base relay client. And once that's done, basically we just need to deploy our simple storage smart contract and pass in this trusted forwarder address based on the network that we have. So to do that, basically you need to go to the website, the Biconomy website, to search for the smart contract address for the trusted forwarder. But here under the list folder, I already have a Biconomy forwarder.json, which I have uh, written down all the Biconomy trusted forwarder address based on the network themselves, so you don't need to do that anymore. And basically these are gonna be the parameters that we're going to pass down the simple storage smart contract depending on the network that we are going to deploy to. And the last one is gonna be the migrations folder, where we'll define all the logic of how we're going to deploy each of the smart contracts. The first one is gonna be the migrations related stuff as well. It's gonna be basically deploy the migrations.sol. Comes out of the box from Truffle as well, so we don't need to touch that. The second one is the one that I custom write. So in here, basically, I'm writing the custom migration script for how to deploy this simple storage smart contract. And as you can see here, first I import the simple storage smart contract by using artifacts.require simple storage. And here, keep in mind that this is not the file name, but instead it's gonna be the contract name that is written right in here, as you can see. So the name of the file could be anything like simple storage 1.2.sol, but basically it's gonna be referred to the name of the contract right here. So it's gonna import the simple storage smart contract and store it into this simple storage variable. And then we're also going to fetch the Biconomy forwarder JSON here by requiring the Biconomy forwarder JSON in the list folder. And then we're gonna put the migration logic within this module.exports. And here, as you can see, the function will have two parameters. First one is deployer, the second one is network. Deployer is going to be used for deploying the smart contract. The network is going to be used to indicate which network are we going to deploy the smart contract in. And this one is going to be referred to in here. If we see to the truffle config.json, these, as you see here, if I scroll down, on the networks field here, right here, as you can see, there are some subfields right here, which is develop, Robston, Coven, Rankaby, and we want to deploy in Avalanche, either Fuji or mainnet. Basically, these are gonna be the network name that is going to be passed down in this network variable. So basically, from there, we can use both of this variable to deploy. First, we need to fetch the Biconomy forwarder by the network itself. So just index it by the network. something like this. And then once we get the Biconomy forwarded by network, we're gonna check whether it's null or not, because as you can see here, some networks are not there for sure. Uh, Obviously, like something like local ganache is not gonna be there. So basically, when it doesn't find the address, and it's gonna return null, and if it's null, then it's gonna be false, and it's gonna just console log that no Biconomy forwarder found in this desired network, something like that, for example. But if it found it, for example, like Avalanche Fuji right here, which we have, then it's gonna be true evaluated by JavaScript, and then it's gonna run this deploy simple storage smart contract. Basically, this is going to deploy our simple storage smart contract to the desired network, and we're going to pass the Biconomy forwarder address as the parameter of the smart contract right here. And since there's just one parameter, we're just gonna pass it as the first one. But if there's 2, 3, or more, you just basically need to add more comma and pass it down in order of the constructor parameter right here. So basically, once all that's done, we just need to deploy our smart contract. And to do that, open your terminal and then click yarn compile to compile your smart contract. And once that's done, basically, you need to deploy your smart contract by doing yarn migrate dash network. And in this case, I want to deploy to Avalanche Fuji, just like that. And if in a few moments, it's going to deploy my smart contract into the Avalanche Fuji smart contract. Oops, something is wrong. Let me check for a moment. In the truffle right here, Avalanche Fuji. Oops, my bad. This should be network, so let's fix that really quickly. And there you go. Seems like all good. And the migration process is going to take a while, so just rest a bit and wait for a while until the whole smart contract are deployed. So once the deployment process is complete, as you can see here, it's basically going to take a while, and maybe there will be some error on your side, so don't worry about it. I have some error a couple of times as well. As you can see here, it's going to run the 2 scripts that we defined on the migrations folder. As you can see, the first one is going to be the initial migrations, which we don't really need to care about. The one that we want to focus on is going to be the deploy simple storage. And as you can see here, it's deploying the simple storage smart contract. And there will be a bunch of information related to the contract deployment right here. But the one that we want to focus on is going to be the contract address, which if we copy right here, we can go to our browser and go to snowtrace.io and check out the smart contract that we just deployed. Snowtrace.io. I think we might need to go to the Snowtrace testnet one, testnet.snowtrace. Yep, there you go. So just paste the address, and there you go. This is basically the smart contract that we just deployed, and as you can see, it's very recent. So yeah, basically that's it. Just really that simple to deploy the smart contract. And if we want to, we can also basically verify the smart contract as well. And to do that, really quickly, we can just do yarn migrate network Avalanche Fuji. Oops, I mean yarn verify network Avalanche Fuji. There you go. My bad. We don't want to migrate the smart contract all over again. So just like that. And we're gonna wait for a few moments. And there you go. And it's basically gonna give us the same address again. And once that's done, basically here, as you can see, it's gonna lay out all the code that we just deployed, including the one that we inherit. And also if we scroll down here, we can also, of course, get the ABI, which if we want to. And other than that, we of course can read the contract directly. So we can basically interact with the smart contract very easily, and it's gonna display all the public storage variables like this and the version recipient, as you can see. And of course, if we want to write the smart contract, we can do that too very easily with the set storage right here and the set trusted forwarder. So yeah, so now that we deployed our smart contract, the next thing we'll need to do is to integrate it to our dapp and using Biconomy and Moralis execute it with a meta transaction. So now we're back to the front end part of the dapp itself. We still need to set up a few more things related to Biconomy, specifically to set up the Biconomy relayer that we talked about before. So to do that, as you can see here in the .env.example, we still haven't have the Biconomy API key that we talked about before. And to do that, basically, we need to quickly jump to the Biconomy dashboard right here. And then here, if you're on the dashboard, just click register to register your dapp and give it any name you want. And then select the network as Avalanche Testnet C chain right here. And once that's done, just create it. And basically, it will create a Biconomy relayer for you. And once that's done, here I already have one for the Avalanche Testnet C chain. We can just go to the view dapp, and right here we need to do two steps before we can enable the meta transaction on our smart contract, on our simple storage smart contract. First one is to add the contract, to register the contract on the Biconomy relayer, and to do that, just add the smart contract name, add the address of the smart contract, the simple storage smart contract from the snow trace, also the ABI, and choose the meta transaction type as trusted forwarder. And then once that's done, just add it. And the other thing that we need is to register the function itself. So other than the smart contract, Biconomy need to know which function we want to enable the meta transaction on. So to do that, similarly, just add new API, and then here we only have simple storage smart contract registered right here. So just choose that, and then we can choose the method that we want to enable the meta transaction as set storage. And then here you can give any name you want, but it doesn't need to be related to this one. And then just click add, and there you go. The setup is finished, and you'll be able to use the Biconomy relayer to execute meta transaction on your dapp. The other thing that I want to point out is that make sure that you have enough AVAX. In this case, actually, like they don't really have one somehow for the Avalanche. But here, if I show you in Coven one, as you can see, there's a gas thing that will indicate how much Ethereum, or maybe like if you're on Binance's BNB and Polygon, it's gonna be Matic. Like how much gas fees do you still have left on the gas tank? And if this goes red, right now it's green, it means it's sufficient. But if it goes red, then basically you need to deposit some more Ethereum, BNB, or Matic into the gas tank using MetaMask, and making sure that there's enough gas fees for the relayer to pay on behalf of the user. But yeah, just that's it. And once that's done, you basically just need to copy the API key. I also have the one for Coven, Matic, and also Binance, and you can just basically copy it right here on the .env.example, the environment variable that are related corresponding to the chain right here. And once that's done, basically we're ready to look through the code and how to integrate Moralis and Biconomy SDK to execute some meta transaction. So first thing first, let's run our dapp. Just yarn started. And basically this will run our React server, and it's gonna take a while, so just hang on a sec. So here you go. It has finished loading, and basically this is how the dapp is going to look like as I showed in the demo earlier. And there's just gonna be one page for this, which gonna render these components right here. So let's go back to our project again right here, and I'm going to close this to hide the terminal. And then the one that we want to explore under the front end code is going to be this src folder right here, because this encapsulates all the UI logics, everything related to executing the transaction. Everything is in here. So the important that we want to see here right here is that, as you can see, if I click on index.js, here, if you can see, there's Moralis provider, which are going to wrap this one by Biconomy context provider, and this is going to wrap our app component right here. And basically, Moralis provider is to initialize the Moralis SDK itself. And similarly, for the Biconomy context provider, it is going to be used to initialize the Biconomy SDK itself. And this is, by the way, custom, so it doesn't come out of the Ethereum Boilerplate by itself. And let's check it out right here under the context for Biconomy provider.js. And as you can see here, there are a bunch of logics like right here. But basically, the most important thing that we want to see is this initialize Biconomy function right here, which is going to be called in the use effect right here every time one of this variable change, especially when the user switch the network. Basically, it's going to run this initialize Biconomy function, and since Moralis SDK integrates well with Web3.js, it fits very nicely when integrating it with the Biconomy SDK itself, as we shall see right here. Now, it looks quite complicated, but let me explain it really quickly. So here, the wallet Web3 variable here is basically gonna be the Web3 provider for our wallet. So this is gonna be fetch from Moralis.enable Web3, and then the next one we're going to define another provider, but this one is going to be from the RPC URL right here, and this is going to be stored in the network provider. And for those who are not familiar, RPC URL is just basically something like a node. So in this case, we are using the Moralis speedy nodes. So right here, and it's basically gonna fetch based on the chain that the user is using right now. So just like that. And once we define these, then we can define a Biconomy object by using new Biconomy and input the network provider as the first parameter. And the second parameter is going to be a JSON object with wallet provider as the first field here. And it's going to take the wallet web3 object and .current provider. And then for the API key, it's going to be the API key that we just input in the .env file before. If we go to biconomy.js here, this is basically where it gets the Biconomy API key. It's getting it from the process.env, which is the environment variable. So once it's done, we have the Biconomy object, and basically this is the Biconomy relayer provider, so that we can communicate with the Biconomy relayer to execute some meta transaction. And then here, basically using the Web3 object that is provided by Moralis right here, from use Moralis. Yep, right here, Web3 from use Moralis. We will able to set the Biconomy relayer provider as the new provider. And once that's done, basically the rest is just an event listener here, where as you can see, when Biconomy is ready or is initialized, basically here we're going to call a callback right here, which going to set is Biconomy initialized to be true. This is a React state, by the way. And then the second one, we're going to instantiate a contract instance, which is also using Web3 this time. And but this is basically using the Biconomy relay provider. Just input the ABI and also the contract address, which is also going to be variable to the chain ID, and then just set it into the contracts React state right here, and there you go, it's done. The other one is an error event listener, which here I just put it to output a notification error, but of course you can do anything inside of it. But yeah, just like that, and basically using all this logic, it's going to initialize the Biconomy SDK and integrate it with the Moralis SDK, and just that easy. And of course, basically when one of these variables change, then it's going to reinitialize the Biconomy SDK again accordingly. Especially, I think it is most important when the chain change, because here, as you can see, the network provider is going to be changed, and also especially for the contract instance, we need to change it as well, because otherwise it'll be error, because the address will not exist right there in a different contract. And once that initialized, basically through the contracts context provider component, we're going to pass down a few value right here, which is going to be is Biconomy initialize, and then the Biconomy provider object right here, and also the contract variable where we define the contract instance using the Biconomy relayer provider web3 object. So once that's done, basically here when the React run the dapp, basically it will initialize the Biconomy SDK and also pass down the variable that we just mentioned before, and those variable will be usable throughout the app globally. So when we check the app right here, it's gonna be defined in this in this in this file right here. And the thing that we want to see is that, as you can see here, this is basically the routing for the dapp itself. And as you can see, there are two routes. The first one is going to be for the home page, and this one is when we're in the home page, we want to render the contract component. And the other one is a redirect component. Basically, as you can see, there's no pad, so it means that any other page that is not home page, it's going to redirect to the home page itself. So basically, this is just gonna be a really simple dapp that only have a single page. So here, to check the contract page, we need to go to components, contract, and index.js right here. And this is where all the UI, all the logic for this page is encapsulated. And the one that we are interested to see is the meta transaction execution. So here is here's the logic for a meta transaction right here. And as you can see, I define a use meta transaction right here, and I define some inputs and transaction params. I think it's very similar to what we have from the React hooks to execute the smart contract. But let us explore further what does this really means. So to do that, we need to go to the hooks right down here and go to use meta transaction. And basically, once we're here, as you can see, the one that is going to execute the meta transaction is going to be on this on submit meta transaction. And this is, by the way, is going to be passed down on the hook. So, oops, sorry. So here, as you can see, there's error if there's an error. And then is meta transaction processing is going to be a variable to indicate whether the meta transaction is still loading or not. And then the third one is going to be on submit meta transaction, which are going to execute the meta transaction itself. And using Biconomy and Moralis, as you can see here, we will fetch the contract from the Biconomy context that we defined earlier. And then from there, we're going to use the set storage method to set the storage data, the string. And then here, as you can see, we're going to use the input from the input right here. Maybe like, let me open a second window so it's easier to see. Yep, it's gonna be this one, right? Just close this one and open this one. Okay. And there you go. So this is going to be the use meta transaction right here. And here, as you can see, the input is going to be the storage form dot value. And the storage form dot value is going to be the input right here. If we edit storage, the storage input dot value is going to be the text that we input right here. So when I type, basically these are going to be the storage form dot value. And then going back here, right here, and then the transaction params is going to be from, and this is going to be from the account, which is basically my account address, and this is account is from the use Moralis hooks right here. And then the second one for the transaction param is going to be the signature type, and the signature type is, as you can see right here, back really quickly, this is going to be the EIP 712 or personal that we are going to choose. And here, as you can see, there's EIP 712 and personal. Basically, the difference is very minimal, but let me show it to you really quickly. Suppose I want to change the string to Moralis, and then I'll just choose EIP 712 and set storage. And a MetaMask prompt should appear really quickly. And as you can see here, there's a bunch of JSON that will appear right here. Basically, EIP 712 is a standard so that it can give the user more info on what kind of JSON object or data that they are signing on. Because if they don't know, then it'll be basically could be like on a malicious side, they could hack you. So yeah, it's basically a better standard for signing. Of course, like you can do personal as well, which is like the one that people usually use. But this one, as you can see, is just gonna give you like some gibberish hashing right here, which people don't know. And this could be basically really dangerous because people really don't know what they're signing on. So best to use EIP 712 in general, but there you go. Those are the difference between EIP 712 and personal on a high level. And yep, this is going to be the one for the signature type right here. So once we inputted this one, this is going to be passed down right here, and it's going to be used on the on submit transaction right here. And as you can see here, basically, yeah, we're going to set the storage, and the input here, the one that we type, the string that we type, is going to be the variable that we want to change the data for the smart contract to. And then we're just going to .send it and input some transaction params that we have right here. And the reason why we do this instead of the usual use Web3 contract or use execute Web3 function from Moralis is that because here we need some further configuration on the .send function, which Moralis doesn't support. So we need to do this. And then basically, if we want to do some event listening right here on the transaction, we can just use here on transaction hash, and then once confirmation, and then also the error event listener. So the transaction hash is basically just gonna execute when there's a transaction hash is given, but you can of course also get it from the confirmation right here, but this is only gonna execute once the transaction goes through or successful. So here, as you can see, I define the callback as set is meta transaction processing to be false, because basically the native meta transaction has finished processing. And also I set the on confirmation right here to be the transaction hash, which I remember this is, I think, this is the callback. Basically, like uh if like the meta transaction is successful, it's going to call this callback. If it's error right here on error, it's going to be calling this on error callback right here, both in here and here. So yeah, just like that, really simple. Basically, then people can just use this to indicate whether the transaction is still loading or not, and this one to call the meta transaction. So here, as you can see, if we search it, basically to do that, it's going to be right here, where on submit, basically once once uh once the user have fill in this new string right here, and also choose the signature type as either EIP 1712 or personal, then basically it will call that on submit function that we have right there, on submit function, and execute the on submit meta transaction right here. And here, as you can see, there's the on confirmation callback here, and also the on error callback right here, which I define a bunch of things right here. So yeah, that's basically how it works. Not very complicated. So just, yeah, now we can basically change it to anything we want, and just Avalanche, and we're gonna choose it to EIP 712 and set the storage. And just like that, we will sign the transaction, and as before, as with the logic that is written on the React code that I just shown before, it will basically change the string right here in the smart contract as we did in the demo earlier. So yeah, just that simple. And that's how we integrate the Moralis SDK and the Biconomy SDK, and using the Biconomy layer to execute a native meta transaction without any gas fees. Hope you guys enjoyed this video, and hope to see you guys soon. Bye bye.